All right, so here is the missing video that's actually disappeared on me, so I am going to shoot it again. So welcome to trig functions. So this is trigonometric functions. This is like Pythagorean theorem with a little bonus. So the big thing that I want you to start to remember is this little acronym. You've probably heard it before. If you've watched any videos, you know it. It's SOHCAHTOA. Now, you notice how I wrote it. Okay, I'm not going to write it. A lot of people just write it the classic SOHCAHTOA, and you can write it that way too. Okay, that way it works just as fine. SOHCAHTOA, what is it? SOHCAHTOA, what is it? SOHCAHTOA. A better way to write it is like this. SOHCAHTOA. Why? Because this actually gives you the formulas as well. Okay, so SOHCAHTOA. What does that mean? So the big thing is that all of these trig functions, there's only three: sine, which is so, cosine, which is coa, tan, toa. Tan is the T. So each one of the letters represents the start of the acronym. These are ratios. Just like pi is a ratio. Pi is a relationship between the circumference to the diameter of a circle. It doesn't change. So this is a ratio. So is sine, so is cosine, and so is tangent. The difference is these are the relationships, the ratios between the side length of a triangle and the angle. And basically what happens is that no matter what, this ratio has to be maintained in one incident. And this is the part that, just like in Pythagorean theorem, you have to always check for. It only works for right triangles. Okay, so these trig functions work for right triangles only. Okay, you get into how to do it with triangles that aren't right later on, but for now, only right triangles. Okay, that's not a right angle at all. Whatever. Okay, so let's dive into it. There's a few things you need to know right off the bat. These ratios set up algebraic expressions that you can solve, just like Pythagorean theorem. So the full sine theory is the sine of an angle, like this, of an angle, let's call it x, equals the opposite over the hypotenuse. So that's the sine law. Cosine law is going to be the cosine, cos, of an angle equals adjacent over hypotenuse. And then the tan of an angle is going to equal the opposite, that's not hypotenuse, that should be A. Good, I'm making errors in the first couple of minutes. Opposite over adjacent. Okay, so this sine, this cosine, and this tangent, they are just different ratios. Okay, you can imagine that if this triangle, this line gets longer, as the hypotenuse gets bigger, the angle actually gets smaller. So that's what these ratios allow us to discover. And they're all on your calculator. You can calculate them by hand, but don't, because it's going to take too long, and in high school you don't have that kind of time. Okay, so let's start taking a look at these. These are the formula triangles that you can use, just like the way I wrote it in the start, where you have sine equals opposite over hypotenuse. So, okay, cosine equals the adjacent over the hypotenuse. Tangent equals the opposite over the adjacent. Okay, now, just like in Pythagorean theorem, we need to learn a little bit of vocabulary. The first one is the opposite. If I am looking at a triangle, okay, remember in this case, they're going to give you an angle. Okay, it's something new. So if they give me this angle over here, this is my angle x. Let's say angle x is 45 degrees. Okay, that's going to make, these are going to be the same length, but whatever, we don't need that right now. So we have to understand what the opposite of the angle, these are all from the angle, the adjacent of the angle, and the hypotenuse, well, that's always the hypotenuse. That never changes. So the opposite, let's do these in different colors actually. Let's do the adjacent in green, the opposite in red. The way I like to think of the opposite angle is it doesn't touch the angle at all. Okay, so here, kind of like if you have an opposite political view from liberal to conservative, they don't match up very much. So if this is an eye, okay, we can actually shoot to the opposite. So this angle, the line that's opposite it is this far side. Okay, so that's the opposite. The adjacent means next to. Okay, adjacent sides are touching. So if this is my angle here, the adjacent side is the one that's going to touch the angle. So this one here is my adjacent. Okay, why is this one not the adjacent? It's a good question, isn't it? I think it is. Otherwise I wouldn't ask it. The adjacent is the leg. This could also be the opposite leg, the adjacent leg of the triangle. Because the hypotenuse gets its own designation in this setup. Because those right triangles, just like in Pythagorean theorem, the hypotenuse sets up a bunch of different other, like a whole bunch of other situations that we can use. Right, so in this triangle, my opposite is the one that is not touching the two angle lines. The adjacent is the leg that is part of the angle, and the hypotenuse is the other. Now, what if we did the same thing, but on the opposite angle? So if this is my angle, let's say it's 30 degrees, what would be the opposite? Remember, the opposite is the one that is not part of the angle. So the hypotenuse and this leg, they make the angle. So that means my opposite would be this one. Okay, the opposite is the one that's furthest away. My adjacent would be the leg, so that means it's attached to the 90 degree. See how it connects the angle to the 90? This is my adjacent. And the hypotenuse is always the one opposite the 90 degree angle. Okay, so this over here would be my hypotenuse. Now you can imagine that depending on which angle they give us, the opposite and the adjacent switch. So for example, if they give us this angle, well, my opposite and my adjacent now have to switch, because this is now the adjacent side because it's part of that new angle. Good. So that's how you kind of see these triangles. I'm going to leave this one up because we'll use it shortly. Next big thing to realize about trigonometry is, as I said, there's more than one way to solve it, because the biggest piece of information that you're going to be using with trig is something called the sum of the interior angles of a triangle. So if I add up all of the angles, I'll go down. Can I do that? Yeah, good enough. I'll make this line a little shorter so you can see it better. There we go. If I add up all of the angles inside of a triangle, I'm going to get 180 degrees. Because in trig we're using 90-degree triangles, that means that these two angles, the only thing I have left is 180 minus 90, gives me 90 degrees. So 90 degrees has to be split between those two angles. Here's a little trick that I learned in university. It's quite helpful. So if they tell me over here that this angle is 30 degrees, okay, so angle x is 30 degrees. Angle x equals 30 degrees. What is my opposite angle? So this one is 90, so that gives me 90, so that takes out half of the degrees. So between these two angles, I have to split 90 degrees. So if I go 90 minus 30, well, angle y is now going to equal what's left over. So angle y is going to be 60 degrees. So I can put this in right away. Okay, I've solved the angles of that triangle. Now I have options. Okay, so let's take a look at just that 30-degree angle, and let's start working some of our work. So if the question is asking me to solve for that side, what do we know? I don't know my hypotenuse, so my hypotenuse is question mark. Currently, I don't know anything. So they have to give us one more piece of information. I don't have enough information to solve this. So let's say this is 10 centimeters. Well, is that my adjacent, or is it my adjacent or is it my opposite? Right, so it's attached to the 30 degrees. So this is going to be my adjacent equals 10 centimeters. Units are important. Right? And lastly, my opposite is my unknown. Opposite equals, I don't know. Okay, so the big thing here is this is not even given to us, the hypotenuse, so it doesn't factor in. So what we notice here is I have my adjacent and I'm looking for my opposite. So now we go up to our trig functions. Which trig function uses opposite and adjacent? Well, it's TOA, right here. Okay, so because I know I'm using the opposite and the adjacent, that determines which trig function I'm going to use. So in this case, I'm going to go tan of an angle equals opposite over adjacent. Now we just fill it out. My opposite is, I don't know. So tan of the angle equals opposite over 10. But I also know my angle. Okay, my angle is 30 degrees. So when I know my angle, now I can put tan 30 equals opposite over 10. Okay, or you could even put in x there because it's our unknown. And this is where algebra comes in. Okay, you have to think a little carefully here because I want to isolate for the opposite. So the opposite is going to be tan 30 times 10. And you literally put that in your calculator. Tan 30, it's going to give you an answer, and then you multiply that by 10. So it's going to give you the value of x. Right? There's also another way where you can shortcut this. Okay, so basically, all that changes is, are we using our hypotenuse? Are we using our opposite? Are we using the adjacent? That's what we're using to figure this stuff out. Now, a little trick on how to manipulate. That was a terrible. There we go. There we go. A little tip on how to manipulate the formulas. There we go. Hopefully, we're sharpened up there. Are we sharp? Good. So the reason I like these is because if I'm solving for my opposite, I know I'm going to use sine of the angle times hypotenuse. So I can even write that after I put my sine angle equals opposite over hypotenuse. But what if they give me, what if the opposite is my unknown? Well, just like we have in every other formula that we've used this year, we could actually rewrite this to be sine of the angle times the hypotenuse equals the opposite. And now this becomes a single entry. Right? This works when we're solving for either of the legs. So if I'm trying to find one of the lengths of the triangle, I'm going to be using these straight formulas because I know what the angle is. Where it gets tricky is when we now have two lengths, two side lengths, like so. Let's go 3 and 4. And they're asking us to find the angle. What is the angle of x? Well, in this one, let's take a look again. Actually, let's put 5 in here. Let's do it a little bit differently so we can use a different formula. So we identify my angle is unknown. I have my hypotenuse here because it's the longest side. Hypotenuse equals 5. And I have, is that my adjacent or is it the opposite? It's attached to the angle, so that's going to be my adjacent equals 4. So I'm looking for something that has hypotenuse and adjacent. So we look at our stuff. Opposite over hypotenuse, no. Adjacent hypotenuse, bingo. That's the one. So it's ka. So the cosine of the angle equals adjacent over hypotenuse. Now, in this case, when we fill this out, I get cos of the angle. It's a terrible. Cos of angle x. Adjacent is 4. Hypotenuse is 5. So you see how we actually have something that's actually starting to solve itself already? Because we could actually calculate 4 divided by 5. Right? That's something that's tangible. We can actually calculate that. The challenge here is that our unknown is our angle. So in algebra, how would we get rid of a times by cos? Because that's all that is. It's like a pi, right? So if I have times by cos, the opposite would be to divide by cosine. Here's where you got to use some of your integer laws though, because if I divide by cos, right, that's the same as doing something we call the inverse of cosine. So cosine to the negative 1 is going to be equivalent by 1 over cosine. That's that negative negative exponent law. So on your calculator, you're actually going to see a button that says cos to the negative 1. And when we use that, what we're actually doing is we're actually dividing by the cosine. So that's how we get rid of the cos ratio when we're trying to solve for the angle. Confusing, I know. So when we do this, the angle is actually going to be cosine to the negative 1 of 4 over 5. So it's like in Pythagorean theorem when we take the inverse theorem, right? When we take c squared, or no, what would that be? A squared equals, or a equals the square root of c squared minus b squared. This is the inverse. So if I'm solving for the angle, I'm actually going to take that cosine and divide by it. That's what the negative 1 is. And this is what's going to show up on your calculator. So it's going to be cos to the negative 1, or the inverse cos, times whatever your side lengths are. And make sure you always hit equals at the end. All right, so that was, I wanted to keep this under 20 minutes. So that's a lot to digest. You've got your main ratios right here. So, ka, toa. When you're doing trig, if you want to write it down, just like order of ops. So, ka, toa. Can't write it myself. Okay, remembering that this is the sine of the angle, cosine of the angle, tan of the angle. The only time I'm ever going to use the inverse is if they give me two sides, 3 and 5, and ask me to solve for the angle. In that case, my trig ratios now become the angle, the value of the angle, equals, like, this one would be opposite over hypotenuse, so this would be sine to the negative 1, opposite over hypotenuse, the order matters. Okay, so this is my inverse formula when I'm using the inverse of my ratio. Other than that, it's just kind of basic algebra to get it done. Hope that helps, and hopefully this was clear enough. Sometimes my camera doesn't focus in so well. Anyway, sorry I didn't post this last week. Hope that helps. Take some notes, bring some questions.